and for joining this particular VMUG session. Today we'll be talking about auto deploy and the zero touch provisioning, which is a new feature that got introduced in 9-month GA, which got released a couple of months back. And let me know if you have any questions, like interrupt me in between, or you can ask the questions in the chat. We'll try to answer towards the end of the session. Next thing about myself, this is Aditya. I work as a software engineer at VCF BU Broadcom India. My work predominantly revolves around virtualization with respect to the deployments and lifecycle management of ESXi and vCenter. Yeah, and I'm happy to share the learnings in VMUG user group. Yeah. Let me bring up this disclaimer slide. I'll pause here for a moment so that you can read it for yourself. Yeah. And let me get to my disclaimer. So any views or opinions expressed here are strictly my own. I am solely responsible for all the content published here. Content published here is not read, reviewed, or approved in advance by VMware by Broadcom and does not necessarily represent or reflect the views or opinions of VMware by Broadcom or any of its divisions, subsidiaries, or business partners. Yeah, with that said, let us get started. So the today's agenda with respect to zero touch provisioning, before we dive into the new feature, let me give you a overview on the legacy auto deploy. What is its architecture? What are its limitations? And then we'll jump into ZTP, which got introduced in VCF 9.1. We'll talk about what are the important components and what is a provisioning workflow with zero touch provisioning. And then we'll see zero touch provisioning in conjunction with VCP. VCP is the vSphere configuration profiles, which is a desired state config that keeps all your hosts in a consistent way. So we'll talk in detail about ZTP plus VCP and its benefits. And finally, we'll cover demos, one which talks about ZTP and other talks about ZTP in conjunction with VCP. Okay. First thing, what is auto deploy? Why did auto deploy exist in vCenter in the very first place, right? So let's say if we have a bunch of physical servers like 1 and 2, we can install our ISO image, we can mount our virtual ISO and perform our installations. Let's say if you want to scale up this particular installation process or provisioning process, right? So it will be a tedious, we need certain automation, right? So in that case, vCenter came up with this intelligent feature which helps you to streamline the ESX host provisioning at scale. Okay, not only that, not only the booting part of the ESXi host, but also it can keep the configuration of hosts consistent across all the hosts. It can do a placement like which particular cluster you wanted to boot a host, like which particular configuration you wanted to import to other hosts. All these things can be done through auto deploy. Okay, and auto deploy has got these important components. First one is image builder. This is one service where you import a particular depot and create image profile. You can customize your depot with different types of whips. Like if you are having OEM specific whips, or if you have driver whips, you can like customize that particular depot and create an image profile, and then feed this particular image profile to a rule engine. The second one is the auto deploy engine. This is the second service where you create rules. Rules as in, like, let's say if you want to boot up a particular host, right? Like where should be the placement be? What is the pattern with which the host should be like booted up? Let's say if I want IPv4 addresses ranging from X to Y, so these particular hosts should be booted to a particular cluster. All these are configured with the rules. So in the demo, I'll show you how do we create the rules, activate them, and boot the host. Okay. Going to the legacy host profiles. So host profiles are basically the desired configuration. What happens is like when you boot up a particular host, you extract a host profile, or like you define all the configurations on that particular host. Like let's say you wanted to configure NTP for the particular host, and then you wanted the same configuration to be applied to other hosts, which gets booted up through auto deploy. So that time you extract the host profile from that reference host and apply it to the cluster level or to the other hosts. So whenever auto deploy boots up the ESXi host, you get this host profile also gets remediated and checks for the compliance and gets remediated. Okay. And the other thing is the Pixie boot infrastructure. So auto deploy majorly relies on the Pixie infrastructure where you need DHCP as well as TFTP. DHCP where you configure the MAC and IP reservations, and also it points to the TFTP server where your bootloader file is present. And TFTP serves like it's like the initial bootloader file that gets executed and which eventually triggers the HTTP boot in the vCenter. Okay. Any questions in this? Okay. And the legacy auto deploy has different types of provision modes or like deployment modes. So you can provision your ESXi host in one or the other ways. Like you can provision it with stateless boot, or like you can have stateless caching, or you can have stateless install. These are legacy ones where the hosts are coming from one clusters, right? Like stateless is basically you don't have a local disk for that particular host, so all your image gets booted into the RAM, and then like upon reboot nothing is persisted, like everything it'll be again re-imaged and be booted with a new image altogether. So that is the stateless, whereas stateless caching is you have a disk, but it is like fallback cache, like it initially when you boot up it behaves like a stateless host, but what happens is upon reboot it actually installs the whips everything onto the disk. So upon the next reboot, it will behave as a stateful host. And there is a stateful install where it's basically like as good as provisioning a ESXi host with a disk on it. Yeah. So even if you reboot, it doesn't get reimaged. It has its own configuration still laying upon. Yeah. Any questions in this slide? Okay. Let me move to the next thing. So what is a provisioning workflow for the legacy auto deploy, right? Like let's say if you power on a particular ESXi host, which is configured with auto deploy. So host powers on, and it requests a DHCP request, and it receives an IP address and the TFTP location. So this IP address and TFTP location is configured in your DHCP server, where you have MAC reservations, and also TFTP location where you specify the IP of TFTP server and the location of the bootloader. And then once you get this particular information, it goes to the TFTP server and starts executing the bootloader, the iPixie bootloader. So these bootloaders in legacy auto deploy, what we do is we basically copy all these TFTP files from the vCenter server into a TFTP server. Okay. And then this iPixie bootloader executes and which initiates the network boot. And then this HTTP boot request starts from the client to the auto deploy server. So what does auto deploy do is it basically has the rule engine, right? Like it will check for the IP address or for the vendor name or a particular UUID, and it matches with a particular rule and sees what image does this host require and what is the location where it has to be placed. So it does this rules evaluation. Then it based upon the image that it fetched from the rules evaluation, it will give the image, and it will install based upon the mode that you have set. It's stateless caching, or stateful install, right? So here, and also you can configure host profiles in legacy auto deploy. So basically you can provision your ESXi host, and also you can keep your config consistent across these hosts. So auto deploy with host profiles gives you better benefits. Yeah. So any question in the provisioning workflow? Sure. Yeah. So now what is the limitation? What are the overhead with this Pixie infrastructure, right? Like, see, this TFTP servers that we generally use are unauthenticated. So you don't have any directory, you don't have any access controls, you don't have any authentication. So blind file reads and writes will be happening. So this TFTP would become a man in the middle attacks, very much prone to this man in the middle attacks, so that your bootloader gets corrupted or something like that, right? And you don't have encryption or integrity checks. They'll so there is no way that you can verify whether I'm installing a correct or like proprietary or proper software which is intended to be installed on the particular ESXi host. And then TFTP basically runs on UDP. So like, let's say it doesn't have any congestion control. Like, let's say if you have a large number of hosts which are rebooted, or like when you are deploying when a large number of hosts, your TFTP can become a bottleneck because it doesn't have congestion control, and you can lose packets, and the booting process might be impacted because of that, right? The same thing, the bootstrap vulnerability, same thing with the host reboots. And infrastructure overhead. Let's say if you want to have multiple TFTP servers to overcome this burden and overcome this performance issue. So this is all the infrastructure overhead. You have to maintain DHCP, you have to maintain multiple TFTP servers. So that is the limitations of overhead with respect to auto deploy, because auto deploy majorly relies on Pixie infrastructure. Yeah. Any questions on this? Yeah. Moving on to the zero touch provisioning. So basically, zero touch provisioning eliminates all this Pixie infrastructure. So you don't require TFTP server at all. You don't require mandatory DHCP server. You can configure DHCP if you want to, but there is no hard rule to configure DHCP also. Okay, what is zero touch provisioning? Basically, it uses UEFI HTTPS boot URL uh, and actually boots up your ESXi host without the need of TFTP. So basically, this boot URL will point to a particular boot file where your bootloader is loaded. So which is within the vCenter. So it boots up without the need of TFTP server. So it combines vCenter level UEFI HTTPS boot URL with UEFI HTTPS boot facility. So this particular facility has to be available in your hardware, like your ESXi host or like the physical servers should have the capability of UEFI HTTPS boot in order to use zero touch provisioning feature. Okay. And you can configure this particular UEFI HTTPS boot URL within your UEFI firmware settings, or you can configure a DHCP server and you can give a boot option as a URL in DHCP server. Okay. And zero touch provisioning has two core components, like it has boot routing service and it has got network boot service. Boot routing service is basically it exposes a single vCenter level HTTPS boot URL. So the URL looks like this. What happens with this is basically this is a entry point. So it is like universal for all the hosts which are booting up. So you just configure this particular URL in your UEFI settings, and then you are done. Like whenever you boot, it reaches to this particular EFI file, which is a bootloader, and it starts the network boot. That then points to a network boot service here. So network boot service is basically you create a cluster specific network boot folders or HTTPS. Let's say you have like 5 to 6 clusters with different images. So it will create a network boot folders for all those images separately. So BRS will actually point to NBS based upon the rules engine that we configure in auto deploy. Okay, I'll show you more in the demo on how it actually gets configured. So the key benefits here are basically UEFI HTTPS boot protocol built for large-scale imaging, a native support of secure boot on these target devices, and also there is a heterogeneous clusters, right? Like earlier, auto deploy doesn't have this support to image ESXi hosts in a heterogeneous cluster. It only images host in the homogeneous cluster. You cannot have clusters with different vendors in auto deploy. Whereas with ZTP, since NBS has a flexibility of creating network boot folders for different images, you can still perform a boot in heterogeneous clusters based upon the rules that you define. Okay. And then you don't have this network infrastructure complexity, no DHCP or TFTP configured. Yeah. So the prerequisites for this deployment is basically your ESXi host must trust the vCenter certificate. Uh, I'll talk about this. And hardware must support HTTPS boot. So this we have already spoken. The physical server should support HTTPS boot. Um, and the first thing is basically when we are talking about HTTPS, there is a TLS communication between the physical server and the vCenter. So in order for us to successfully provision ESXi host through vCenter, we needed a vCenter certificate to be trusted by the physical server. Okay, so that is one way. The other way is like, let's say you have physical servers. I mean, the modern enterprises have all the physical servers which are already signed by public CAs, right? So if they are publicly signed with those public CAs, then you don't have to worry about. If there is no such signed, or like if there is no such root certificate installed in your UEFI firmware, that is when you need to upload your vCenter's root certificate into your UEFI firmware settings for a successful ZTP boot. Yeah. Any questions here? Okay. Yeah. So we'll dig deeper about the core components. First one is the boot routing service. So as I said, this is like the universal entry point. So you have this particular URL. I'll show where we can get this URL once we have vCenter server appliance, right? And this is like BRS is like a single global HTTPS entry point for all the target systems. So when you provision ZTP, what actually happens is will expose this particular endpoint to all your physical servers. Then when the host is powered on, it evaluates all the hardware attributes of your physical server, such as UUID, MAC address, IP address, all this. And these attributes are sent to a vSphere boot manager in the vCenter. So based upon the rules that we have created, it will check for the attributes. Like let's say this particular IP has to be placed in a particular cluster with this particular image. Based upon that rule, it will query this centralized auto deploy rule engine to do this target destination mapping. And then BRS issues a redirect to appropriate cluster boot URL to NBS. So BRS has a universal entry point. It takes up the attributes, searches the rule engine, and then points to the NBS specific URL. NBS is basically for every cluster, it creates network boot file folders with all the boot bank and all VIPs configured like present in that particular folder, and which will have a particular URL for that, and which gets propagated to BRS upon request. Yeah. So these are the two core components. Any questions? Okay. Yeah. So this is my physical Dell ID rack system, which I took a snapshot from. So if you see this, right, like you have questions. Sorry, I Q&A. Yeah? Okay. Yeah. Okay, let me just take a few questions and then we'll continue with the presentation. First one is, as per security practice, Pixie environment is also separate from ESXi management network. Any new changes in best practice for VACF ESX9 for any better option is available? Ankit, I didn't quite get the question here. Can you just reword? What do you mean by it? Yeah. The second question is from Prasanna. So for BRS needs to have rules created for each host mapping. Uh, so BRS doesn't need any rules to be configured. Like BRS is a separate service. We need to create rules in the auto deploy. I'll show you a UI where you create the auto deploy rules. So each rule can have multiple hosts or a single host, or you can customize the rules based upon the requirement. Like let's say if you want to um, boot from ZTP, you can configure ZTP for that particular cluster. Or if you want to boot from a stateful cluster, you can actually do that. Rules of I'll show you it in the demo. It'll be clear. So how do we configure those rules? But BRS doesn't need to have the rules explicitly, because it's a separate service which is tied with VLCM component. Yeah.
Aditya, I can reiterate that question Ankit has requested. So look, typically what happens on any core infrastructure,
Yeah.
we have two different, VLANs or dedicated networks. One typically for Pixie, which is used via DHCP to provision the machines. Okay,
Correct.
for installation purpose. Once that is done, it on the other interface we also used to configure a management network, and using that management
Right.
network, just try to get into the machine, right?
Yes. Yes.
So
Correct.
that is the reason, as Pixie environment is always assigned or dedicated with DHCP, we always prefer to keep it separate, because management interface we do not want to lose with the
Yes.
DHCP, right? So
Correct.
that's what his question is like. Is there anything changing from VCF ESX9 perspective regarding to
No,
that separation?
I mean, we still support the Pixie environments. But like, let's say if you are asking about the security practice for Pixie environment, so generally, I think the recommendation is to use these type of infrastructure in an isolated networks, so that the weak links are like not much exposed. So that's one thing. And the other thing is like this, we still support auto deploy with Pixie environments. It's not deprecated. Only thing is like we have added a new feature where if you want to have a secure boot or like UEFI HTTPS boot without Pixie infrastructure, you can leverage the zero touch provisioning feature. Yeah. Let me know if my answer didn't convince you. Yeah. And the other question is, does NBS support S3 storage? Or what is the maximum number of ESXi hosts supported for ZTP? First thing is NBS is basically at the vCenter level. So it actually creates all the boot bank files within the vCenter file system. So ideally, it doesn't support any S3 storage, as far as I know. And the max number of ESXi host support for ZTP is, you need to check the config max document. So ideally, we have tested like parallel deployments of ESXi hosts through ZTP, somewhere like 64 hosts. But this number may vary. You need to double check the config max. And the other thing is, there is nothing like hard and fast rule for number of ESXi supported for ZTP. You can like boot your ZTP, but this is like the parallel execution. Like parallelly, we have tested like till 64 hosts that can be booted up through ZTP at once. Yeah. Okay, I think we are done with the questions. Like, let's move to the next slide. Um, so this is the Dell ID Rack HTTP boot configuration page. So if you see the URI here, right? So this is the one that I was talking about. So we'll provide this BRS URI here. So which is the universal entry point for all your boot files. Uh, this is one way of doing it. So if you want to create like assign static IPs, and if you want to specify the URI, you can do it in the UEFI settings. But let's say if you do not want to use this static IP, you can use DHCP to provision your to allocate your IPs, and also provide a DHCP boot option with this URL pointed out. Okay. Yeah. And other thing is like, as I mentioned, like the TLS authentication configuration. So you have this TLS authentication configuration where you can add your cert, like CA cert, like, the vCenter CA cert, so that uh, it gets trusted when you do a secure boot from your ESXi host. So that's the note here that we are mentioning. Whether the server trusts vCenter HTTPS boot or URL out of the box or needs manual cert push depends entirely on the CA. Public CAs are already pre-trusted in the firmware. Internal VMCA issued certs are not, and require extracting and loading those root CA thumbprint into UEFI trust store first. Yeah. Any questions? Like, so this is the preparation part of your ESXi host. Like if you have physical server, you can configure the static IPs and you can provide the URI, or you can have a DHCP server which has MAC IP reservations, and also the URI for your booting. Yeah. Moving on to the next slide. So this is the ZTP workflow. First is, as we already told, you have two options, like use DHCP or use static config. So DHCP server returns the BR's boot URL. Static, already you have configured the UEFI settings. Then once you have this URL, it will start your first stage bootloader, which actually starts the network boot over HTTPS. Then you get all these host attributes like SMBIOS, network config, hardware info, all this. And basically it matches the device based on the rule engines. So matches the device to target level. Here auto deploy comes into picture, where BRS asks auto deploy whether this particular host has got any rule activated. So based upon the rule, what is the NBS URL? So then it will redirect to the NBS, gets the NBS URL, starts the image payload and install. So this is your ZTP boot workflow. So overall, we are avoiding the TFTP infrastructure altogether. Yeah, and which is secure altogether. And the last one is basically ZTP in conjunction with vSphere configuration profiles. So vSphere configuration profiles, I think this got introduced at 8.0 time frame, where this ensures you have consistent configuration applied to all the hosts within the cluster. So what happens is, like, whenever you boot through ZTP, a host get placed in a particular cluster. You extract, you configure that particular cluster with configuration profiles. You extract the configuration profile from that reference host, do all your configurations like configure your NTP, configure your DVS switch, everything, and then apply it to the cluster. So what happens is, like, whenever a next host boots up into the cluster through ZTP, it gets auto remediated. So what I meant by that is, like, the settings gets remediated onto the ESXi host, which is booted to that particular cluster where VCP is enabled. Okay. So ZTP in conjunction with VCP is similar to auto deploy in conjunction with host profiles. So those are the legacy ways. These are the better ways, like ZTP plus VCP is secure, as well as VCP is like a human readable JSON. You can make changes here and there, and you can apply these configuration profiles, check the compliance, and remediate all the hosts. Okay. Any question? So in the demo, what we'll show is basically we have VDS bootstrapping. We'll configure a reference host where we configure VDS for that particular host, extract the configuration profile, apply it to the cluster, and then perform ZTP for other hosts and see if that gets remediated. Yeah. So any questions before we move on to the demo? Okay. First. Let me know if the audio is not sufficient. Yeah, welcome to the demo. Currently, we have a vCenter deployed with 9.1GA build, and the inventory comprises of a data center and a cluster. As we already discussed, Auto Deploy has two important services. One is Image Builder, where you can configure the image profiles and customize the images. And the other one is the Auto Deploy itself, which is the rule-based engine. So in order to go to Auto Deploy, you need to click on Auto Deploy icon here. And by default, when a vCenter is deployed, both the services will be inactive. So if you look at the WAMI page, currently auto deploy service and image builder service both are stopped. And if you can see, the startup type is manual. If you want to run auto deploy, you need to enable both of these services and maybe change the startup type to automatic to persist the state even after VC reboots. Yeah. Currently, we'll enable auto deploy and image builder. So you can see the UI of auto deploy where it shows clusters, software depots, deploy rules, and others. So in the first tab, you see the clusters. The clusters in the inventory are part of this particular tab. By default, the provisioning method is set to auto deploy stateful. So you can modify or transition to different provision methods like enable zero touch provisioning or enable auto deploy stateless. Since our demo focuses on enable zero touch provisioning, we'll come and enable this particular flag. Then there is software depots. This is where image builder comes into picture. This is where you import your depots and you customize your images, create a new image profile, and use them in the deploy rules. Yeah. The next tab is on the deploy rules. So you can create a deploy rule. You can name test rule. It has test rule one. You can you can basically specify all the hosts which are like booting up and talking to this particular auto deploy service, or you can select based upon the pattern. Currently, we have different types of pattern matching, where it's asset, domain name, or host name, IPv4, IPv6, UUID, vendor, all this. Currently, we'll use IPv4, and I'll specify 216.62, 200, 172, 1663, 30. Sorry, it should be 63. Yeah. Sorry to interrupt. So here, if you can see, we are configuring two hosts for this demo. So both of them have different IPs. So I just used comma separated values for them. Let's say if you have a particular range, like let's say from 172, 1663, 1 to 200, if you want to specify, you can just specify that particular range. You don't have to specify each and every host with their IP address. Okay. Yeah. Next. And you want to specify the host location. Next. And use ZTP demo. Next. You can do finish. Basically, your deploy rule is being created, but it is still inactive. Okay, we'll come back to this rule again. And then finally, you can go to the configure tab. And our interest is basically on the zero touch provisioning. As we discussed, we said there is something called boot routing service, which exposes a vCenter URL, which is like the entry point for UEFI boot, right? So you can find this particular URL. You can either present this to your DHCP server to boot, or you can add it to UEFI firmware settings. Okay. Then going back to the clusters, let us just enable zero touch provisioning. I'll show you the tasks. Sorry. I'll show you the tasks once we enable zero touch provisioning. What are the tasks that gets triggered? See here, it basically is enabling a network boot. That means it is basically creating a network boot bank for this particular cluster. So here the network boot bank is basically a network boot folder, which I spoke about, right? Like the NBS is the one which is responsible to create the boot bank with all the bootloaders and your VIPs. So if you have different clusters with different images, NBS is capable enough to create NBS folders for all those clusters. And other noteworthy thing about NBS is, let's say you have 5 to 6 clusters, and you have like some image which is being used across all these clusters. Let's say you have custom images, but most of it is like common. So they have a deduplication feature. The NBS has this deduplication internally so that you don't run out of space in the vCenter. So this is where network boot service comes into picture. So this is actually creating a cluster specific boot URL. Yes. Now we have already created deploy rule. Let us activate the rule. The rule is active. You can see the image is VLCM image picked from the cluster. So basically, we have this test rule one, which points to ZTP demo. So the image that has been imported to this particular cluster gets picked up by all the ESXi hosts which are booting up here. So in our case, it's 230, right? So I've booted a physical machine. You can see this boot routing service, vCenter boot menu. It'll take some time. So I've booted this particular ESXi host. So since the ZTP is configured for this ESXi host, so this started to boot. It starts looking for the BRS URL that is configured and looks for the rule engine, and this is how it finally goes to the NBS URL. If you can see the NBS URL, it says vmw/nbs/clusters domain C11. So domain C11 is your mob ID of your cluster from your HTTPS location, right? You see, this is the location where network boot service has created your boot bank and all of your webs and started to load in your ESXi. Okay. And going back to our vCenter, you can see this network provisioning host. It shows the current status when a particular host is booting up and being added to the cluster. I'll just fast forward this installation process. Host is, yeah. You can see now the add host operation has been performed once the ESXi is booted up. So let us go to our inventory and see the host has come up with the image that is being imported on our VLCM cluster, right? Yeah. So this is the first demo which talks about ZTP workflow process. Any questions in here? Yeah. Yeah. Does VCP support AD domain unjoin? I have observed that when we use VCP using JSON desired state config, the existing host joined to the AD, which I Prasanna, I think this is more of a vSphere configuration profile question. Um, so maybe you can I'll check and I'll get back to this. Yeah, yeah. I'm not sure at this point of time. Yeah. Thanks. Okay. So the next demo is on the ZTP plus VCP. Welcome to the second demo, where we are presenting VCP, vSphere configuration profiles along with ZTP. Before this demo, right? So what we did is we basically booted up one host using ZTP. So now, before I recorded this particular session, what I did is I configured DV switch on this particular host, which I'll be showing now, and then extracting this particular configuration profile and applying it to the cluster. Okay. So in our previous demo, we have booted up this particular host. And if you look at the configuration, we have configured it with the distributed switch, and we have assigned our management IP, and uplink is configured, and we also have a standard switch, right? Now, what we do is we create a configuration profile. Click on the cluster, go to configure. Under desired state, you have configuration, create configuration, import from reference host. So we'll take this as a reference host. Click on next. It's validating the configuration against all the hosts in the cluster. Since there is only one host, which is a reference host, it will not show you any issues or complaint issues. So it shows the impact preview. Finally, finish and apply. This creates a desired state configuration, which is currently applied to this cluster. So whenever a new host boots up into this cluster, if it is through ZTP, then auto remediation will kick in. So the host is kept into maintenance mode and the host will get remediated and exits the maintenance mode if there are no issues found. Okay, let us boot another host 30. Yeah, before booting up, right? So one thing to talk about the auto remediation, right? Like, so auto remediation is also a new feature that came in 9.1. So what it actually does is, like, if you have VCP, you have the remediation settings. If you set the auto remediation to true, it basically remediates all the hosts. Like whenever you add a new host to a particular cluster, it gets auto remediated, right? So, but for ZTP, by default, the auto remediation is set to true. So, whichever host that gets booted up through ZTP, this remediation kicks in. So the host is initially kept in maintenance mode. Then the remediation will kick in. Once the remediation is successful, it exits the maintenance mode. So that's how it is. Yeah. We started to boot host 30. You can see since the rule is active and we have configured zero touch provisioning, boot routing service will come into picture and the host started booting up. And if you go back to your vCenter and look for the task, there is a host that is being provisioned. The host is booted up, and as you can see, since the configuration profile is applied to this cluster, the host is kept into maintenance mode, and then the remediation will start in some time. There is a remediate cluster configuration which has been triggered. So this is part of auto remediation feature. Uh, when we configure ZTP, the auto remediation feature gets enabled by default if VCP is enabled. As you can see, a distributed switch has been configured to this particular host whose management IP is configured along with the uplink. And also you have a standard switch, which was default for that particular host. Yes. So that's all with the demos. Any questions anybody has, you can take it.
Yeah, I think, I mean, if anyone wants to raise your hand for any questions, feel free to, or you can put it in the Q&A section also.
Yeah.
So we are okay to take the questions here.
One thing to specify is like this ZTP is like the beginning, right? Like, so there are multiple other features that are being built upon this ZTP to enable VCF and all this stuff. So since we are not entitled to talk about the ongoing features or something, you can hear more of it in the next releases. Yeah,
Okay,
I think, yeah,
I think we are good for now. There is no question.
yeah.
So thanks, Aditya. I think one question we are getting from Siddharth. Hi, Siddharth. I have allowed you to talk, so maybe you can ask your question directly.
Hey, hi, thanks for the question. It's really eye-opener. I really like the session. So about the new feature, you said it's stateful, right? Uh, how about getting this feature enabled in an already existing cluster? You have newly configured a cluster, right? For example, if I already have 8 hosts in a cluster and I want to enable this feature to add few more hosts in the cluster, is it possible to do that? And do I have to be
Yes.
precaution about anything if I want to do it in existing cluster?
Yes, Siddharth. Yeah, actually, we do have. So we can actually change the provisioning methods. So there is a support matrix in our documentation, VCF 9.1 documentation. If you pull up, so we basically have, like, let's say you have a cluster which is already stateful. Okay, which is already stateful. Then you basically can change it to ZTP, which it will create NBS boot folders for the particular cluster, and then you can create corresponding rules and then boot up the host. Yeah. So there is a explicit matrix in the documentation. If you visit that page, you will see which are eligible for these transitions, which particular clusters can be moved from one mode to other mode. Let's say,
Right.
suppose if you have stateless cluster, right? Like if you have stateless cluster, you will not be able to move to ZTP, which is not allowed. So there are some restrictions and there are some capabilities to migrate from one mode to another mode for the existing
Right.
clusters.
Do you have reference? Can you share the URL
Yeah,
to the documentation?
yeah, we'll attach that documentation. Yeah, I'll share it.
And the example you showed is a stateful deployment, right? So in
Yeah.
that case, like in case like if the vCenter goes down or if the auto deploy service goes down, there won't be any issues to the running ESXi host, right?
No. Once ESXi host is booted up, there is no issue. If it is stateful, right? Like there is no issue. Even for stateless also, there won't be any issue because it's already loaded into the RAM, right? Like so, auto deploy doesn't worry about. But if a stateless host reboots and then auto deploy server is not available, then there is a problem. But for stateful hosts, there is no problem. Even if your auto deploy service is down, it doesn't hamper your ESXi host.
All right, sir. I think
Yeah.
I got the link to the document. Thanks a lot.
Yeah. Yeah, sure. Thank you, Siddharth.